Yes po, sir. Yes po, sir.
Yes daw. Talaga lang ha? Jeric Aguado, ano yung nilagay ko doon? Ano yung next topic natin? Nako, Mr. Aguado,
Hydraulics conductivity po.
hydraulics conductivity, ba't parang naging isang subject na? Parang naghalo na. Okay. Share ko lang ang screen. Ayaw. Okay, so that is correct, no? Meron po ba?
Yes po, sir.
Okay, so nag-review naman, no? Nakapag-open naman ng video si Aguado. That is regarding hydraulic conductivity. No? So napahapyawan na kayo dun sa hydrology, no? Yung mga ibang terms dito, medyo familiar na kayo, tama? No? Napahapyawan nyo ba to sa hydrology or na-discuss talaga?
Papaya po, sir. Ano na po yung sa Darcy's Law?
Yun, no? Darcy's Law. No? Kasi nga, this is useful also regarding ng mga hydrogeologists. Itong term na nga, may water no? So, nadidiscuss din ito. Just like compaction topic, nadidiscuss din sa surveying and transportation engineering. So, related talaga lahat mismo ng subjects natin. Okay, so, good morning po sa inyong lahat. Let's have our next topic, and that is regarding hydraulic conductivity. When we say conductivity, we are analyzing a flow, no? Parang sa circuits nyo lang noon, no? Kaya lang hindi hydraulic or hindi tubig mismo yung ina-analyze natin. No, so here we are going to analyze the flow of water in a soil sample. No, as the name implies of the topic. So we will be discussing the procedures for the determination of the value of hydraulic conductivity of soils in a laboratory method, in field tests, and also we have also approximation or estimation equation on how to compute hydraulic conductivity. No, kapag hindi tayo magkakonduct mismo ng laboratory and field test. No, parang sa compaction lang ni noon. Sa compaction, merong laboratory test, merong field test, merong empirical relations on how to estimate the value. No, ganun din dito yung topic mismo, yung mga subtopics kay hydraulic conductivity. So, for the lecture part, it says here, soils have interconnected voids through which water can flow from points of high energy to points of low energy. No? So from that alone, we can say that hydraulic conductivity is a property of soil which permits the passage of water through it. We're going to analyze the movement of water in a soil. Saan ba daw nagfo-flow yung water sa soil natin? Doon daw sa mga voids natin. Dahil yung mga void spaces na mga lupa natin ay interconnected to each other. No? Usually. But not all kinds of soil interconnected yung voids. Pero po pwede nating sabihin na in general, interconnected yung voids ng mga soil natin and doon magpo-flow yung water natin. No, from high energy to points of low energy. Doon natin malalaman, dapat magbe-base tayo sa high energy papunta doon sa low energy para alam natin mismo kung saan nag-uumpisa yung point of flow natin. No, not necessarily na mas mababa or mas mataas yung point na yon. And then compared sa mas mababa, sasabihin na natin pababa yung way ng kanyang pag-flow. No? Ibe-base natin mismo sa pinaka-high energy. When we say energy, na-discuss na mismo yan kay fluid mechanics. No? So here, we're going to apply Bernoulli's equation later on. And sabi dito, why do we need to study hydraulic conductivity? Ano yung importance? First one, it is necessary for the estimation of the quantity of underground seepage under various hydraulic conditions. It is also used for investigating problems involving the pumping of water for underground construction. And yung pinaka-importante sa lahat, medyo mas na-apply natin talaga. Medyo maingay sa labas. It is used for making stability analysis of earth dam and earth retaining structures that are subjected to seepage forces. Kasi nga mga mabibigat na structures na yan. So, titingnan natin kung meron mga seepage forces sa lupa natin. Dahil kapag may seepage forces doon, medyo nakakapanghina ng strength ng lupa yon. No? And then yung lupa yung magkikerry mismo ng lahat ng mga forces na ini-induce ng ating mga structures. So, titingnan natin kung yung lupa ay sapat mismo para ma-resist yung weight and all the forces ng structures na ilalagay natin sa ground surface. No. Now, let's analyze the given figure here. No, para ma-analyze natin yung flow. Mapapansin yung flow natin, it comes from this point. Nandito yung inflow natin, nandito yung outflow. No. So, dito magi-start yung flow. Ibig sabihin, dito sa point na to, dapat mas mataas yung total energy natin or total energy head. No? Paano natin malalaman kung mas mataas yung total energy head? Depende mismo sa level ng tubig. Kapag maglalagay tayo ng piezometer dito sa point na to, dapat mas mataas yung level ng tubig doon. Mas mataas yung makocompute nating total energy head. And as you can see here, at point A and at point B, if we will be comparing the total energy head between these 2 points, mas mataas yung total energy head at point A. No? So malalaman natin na yung flow natin ay mag-start from point A papunta kay point B. Pag yung point B, nandito yung kanyang level of water, kahit na mas mababa yun, nandito yung level of water ng point A, yung flow natin ay mag-start kay point B, papunta kay point A. No? Dahil mismo yun yung ating definition. The flow will start from points of high energy, papunta sa low energy. No? Hindi sa nakabase sa elevation mismo ng point na kino-consider. No? So, raise lang natin to, no? And according to Bernoulli's principle, sa ating fluid mechanics, the total energy head at any point is the summation of 3 heads. Meron tayong pressure head, meron tayong velocity head, and elevation head, represented by this equation. Ito yung total energy head. U over gamma of water is the pressure head due to the pressure of the water flowing at the soil sample. And then V squared over 2G is the velocity head due to the movement of water. No, kung gaano kabilis mismo yun or gaano kabagal. And then Z is the elevation head. No, with respect mismo sa datum line natin. No, so yan yung ating Bernoulli's principle, and you are already familiar with this equation. No, nandito na lahat yung mga parameters involved in that equation. Kaya lang, yung velocity daw mismo ng lupa or yung velocity mismo ng fluid or the water flowing in a soil sample ay napakabagal. No? Kasi nga, madami pang blockage sa way niya. May solid grains yung ating lupa. Tama? May mga voids. Kaya lang, hindi naman natin maisaktong magfo-flow talaga sa void spaces. There are instances, magfo-flow siya sa mga void space na yun, pero mababangga muna yung kanyang, ibablock muna yung kanyang way, ng mga, ibablock ng solid grains yung kanyang way. No? Tatama sa mga solid grains muna yung passage niya. So, nagiging mas mabagal siya. Ngayon, kung mabagal mismo yung velocity, mababa yung value. Maliit yung value ng velocity. Eh ngayon, para makompute natin yung velocity head, i-square pa natin yung velocity. No? Yung maliit na value, say that is 0.01, kapag in-square nyo, mas lumiliit pa yung value. Tama? And then, i-divide mo pa siya ng 2G. So, mas lalong nagiging mas maliit. That is why, sa ating principle ng Bernoulli's equation, dinidisregard natin mismo yung velocity head when it comes to the flow of water in a soil sample. Negligible yung value. There is a value, but compared to the value of elevation head and pressure head, napaka-konti nung value ng velocity head. That is why nagiging ganito lang equation ng total energy head natin. No, kung mapapansin nyo dun sa figure, the total energy head at point A is a combination of pressure head and elevation head. No, same with the total energy head at point B. No? Na kung mapapansin nyo, merong difference between the total energy head at point A and at point B. And that is represented by this symbol, delta H. What is that delta H? That is the head loss. No? The the loss energy, no, when it comes to or with respect to the total energy head, that is the head loss. No, and then familiar na kayo dyan, no, palagi na kayo nag-solve kay fluid mechanics tsaka hydraulics ng head loss. Now, how can we compute the value of head loss? As you can see here, this vertical line HA is equivalent to the summation of delta H and HB. So tra-transpose mo lang sa yung HB dun sa kabila, we can say that delta H or the head loss is the difference between the total energy head at point A and the total energy head at point B. No, HA minus HB. Eh ano ba yung HA? Ito yung equation. Minus, ano ba yung HB? Ito yung kanyang formula. Summation lang mismo ng pressure head tsaka elevation head. No? And then sabi dito, yung ating total head loss, delta H, can be expressed also in a non-dimensional form represented by this equation. That is I equivalent to delta H over L. What is that variable I? That is what we call hydraulic gradient. No? And that is equivalent to delta H. That is what we call head loss. Ano yung L? That is the length of flow, the length of soil. No. Ngayon, nasan yung length of soil or length of flow? Nandito yung L, from point A to point B. And that length of flow or length of soil sample should be parallel to the direction of flow. Kung nandiyan yung direction ng flow, yung length na i-consider should be parallel. No. Siyempre, yung flow na yan, magfo-flow at a cross-sectional area of soil. At a cross-section of soil. No, yung cross-section natin, hindi natin nakikita, straight line lang dyan. No, pero kapag titingnan natin sa gilid, merong area mismo yan. And that should be perpendicular or normal to the direction of flow. No? So that is the hydraulic gradient. Nandun mismo yung head loss. So pwede daw natin kunin yung value ng head loss using this equation. Sabi dyan, non-dimensional. Kasi nga walang dimension dahil ang head loss ay parameter of length. Ang length, syempre parameter yan ng length. L over L is cancelled. Walang dimension, walang unit. No? If we are going to use this equation. No? Now, nag-conduct ng study si Henry Darcy. No? And then na-develop niya yung Darcy's law. No, inanalyze niya mismo yung flow ng water or any fluid flowing in a soil sample. No? Yung fluid lang kasi natin usually water, no? Dahil water talaga yung nagfo-flow sa lupa natin, no? Okay, so now, inanalyze niya yung flow and then, kinuha niya yung velocity and then yung hydraulic gradient. And then, kinorelate niya yung dalawang values na yon. No? And then, graph niya, eto daw yung graph. May pagka-parabolic. No? Inassume na may pagka-ganyan, may pagka-curve. Pero, eto talaga yung forma niya. This one. No? At the first stage, nahati daw yung flow sa tatlo. Zone 1, Zone 2, and then Zone 3. Zone 1 is the laminar flow. Zone 2 is the transition zone. And then Zone 3 is the turbulent flow. No? At the first stage, straight line yan. No? Kapag tumataas mismo yung velocity, tumataas din mismo yung value ng hydraulic gradient. No? There is a linear relationship between velocity and hydraulic gradient. And then, pagkatapos mismo dito sa point na to, magiging pa-curve. Ito. This is the actual representation of the correlation of the value of velocity and hydraulic gradient. Ngayon, pwede rin naman daw natin siyang express as straight line. No? In-assume natin straight line siya. So itong curve na to, ginagawa natin straight line para at the transition zone, yung relationship ng hydraulic gradient and velocity is still in a linear relationship. No? And then dito sa zone 3, turbulent flow, Medyo pabago-bago na, no? Tumataas, bumababa, tumataas. Wala nang linear relationship sa point na yan. Ibig sabihin ng turbulent flow, disturb yung flow natin. No? Nagets po? O pwedeng bumibilis siya at that point and then babagal ulit and bibilis ulit. And then dito sa laminar flow, napaka-smooth lang ng flow. Kumbaga, walang yung mga flow ng tubig nasa isang path. Hindi sila intersect to each other. No? Kaya napaka-smooth ng flow. That is laminar condition. Sa turbulent flow, napaka-disturb. Bibilis, tataas. Or bibilis and then babagal. Kasi nga, nag-intersect sila yung flow. No? So kapag na-intersect, nagkakaroon ng mas mabilis kasi nga naghahalo-halo na yung flow natin, no? Mas bumibilis yung velocity at that point. May intersection. Kaya napaka-disturb at this zone 3. And then sabi ni Darcy, in most soils, the flow of water through the void spaces can be considered as laminar condition. And then under the laminar condition, there is a linear relationship. Pag linear relationship yan, we can say that velocity is directly proportional to hydraulic gradient. So kapag gagawin mong equation, maglalagay ka lang ng proportionality constant K. No, ito na yung Darcy's law na tinatawag. That the velocity is directly proportional to hydraulic gradient. Ano yung mga involved sa equation na yan? Ano yung mga parameters involved in that equation? Yung V dito is what we call discharge velocity. No? Sometimes it is also called theoretical velocity. Pag minsan superficial velocity. No, yan yung mga iba't ibang terms ng discharge velocity. Ano daw yung discharge velocity? It is the quantity of water flowing in unit time through a unit gross cross-sectional area of the soil at right angles to the direction of flow. So it should be normal. No? Take note, it is flowing in a gross cross-sectional area of soil. When we say area of soil, sa soil na term pa lang, that is totality. No? Ibig sabihin, papasok siya sa whole area ng soil sample natin. No? And then K is the hydraulic conductivity. And then I is the hydraulic gradient. Ngayon, meron pa tayong isang term dito na binanggit, which is the actual velocity of water. Sabi nga natin kanina, saan daw magfo-flow yung ating tubig? Sa mga interconnected voids. That will be the actual condition. No? And sabi dun sa discharge flow or theoretical flow, yung lupa o yung tubig magfo-flow sa gross cross-sectional area. No? So ibig sabihin na isasali natin mismo yung solid. Dahil ang lupa, kino-contain or kino-compose mismo ng solid at saka voids. And that voids is having a water and air. Ang actual condition daw, doon yung tubig nagfo-flow sa void spaces lang. Pero sabi dito kay theoretical flow, yung tubig magfo-flow sa gross cross-sectional area of soil, totality. So naisali niya yung solid. No, but in actual condition, the actual velocity of water it is flowing through the void spaces. No, and that is what we call seepage velocity. Pag minsan, tinatawag din niyang true velocity. Pag minsan, tinatawag din niyang interstitial velocity. Yan yung mga terms natin. No, pare-parehas lang yung mga pag nabanggit yung mga yan. Pero sabi dito, actual velocity or seepage velocity is greater than the discharge velocity. Tama, kasi nga walang blockage. Yung theoretical flow, magfo-flow sa gross cross-sectional area. Papasukin pa niya or magfo-flow pa siya sa solid. May blockage. Yung ating actual flow, nagfo-flow lang siya sa void spaces. Walang blockage talaga. Kaya mas mabilis yung seepage velocity compared kay discharge velocity. And that makes it greater than with respect kay discharge velocity. And ito yung relationship daw yung seepage velocity tsaka discharge. Nire-relate sila ni porosity. Bakit naging ganyan yung equation? let's consider this figure. No, nandito yung flow natin. Nandito yung inflow, nandito yung outflow. No, as you can see in this figure. So, merong cross-sectional area yan. Hindi natin nakita. Pero kapag tinin natin dito, circular yung kinonsider. No? So, ito yung cross-sectional area of soil. Kapag papasok dyan yung tubig sa whole area na yan, that is under theoretical flow. No? Yung total area of soil is a combination of the area of voids and area of solid. Dali yung composition niya. Ngayon, kapag yung flow natin, yung tubig, mag-flow lang sa void spaces, that is the actual flow. No? Yung flow rate natin sa theoretical condition, yun din yung flow rate natin kay actual condition. No? Mas mabagal lang mismo yung flow natin kay theoretical, and then mas mabilis lang mismo yung flow natin kay actual. Pero same amount of water yung nagfo-flow doon. No? At different time. No? So still, the flow rate will be equivalent. No, in theoretical and actual condition. Pero sabi natin kay hydraulics or fluid mechanics, ano ba yung flow rate? That is the product of cross-sectional area and velocity. Tama? So, this flow rate, theoretical condition is area times velocity. Ano ba yung area na kinoconsider kay theoretical flow? The total area. Ano ba yung velocity na kinoconsider kay theoretical flow? The discharge velocity. So, ganyan yung ating equation. Flow rate pa din yan, actual. Ang sinabi natin, flow rate is area times velocity. Pero ano yung area na kinoconsider kay actual? Area ng voids. Ano yung velocity na kinoconsider kay actual flow? Seepage velocity. No? So these two parameters are equivalent. Ngayon, yung total area, as you can see in this figure, that is equivalent to the summation of area of voids plus area of solid multiplied by discharge velocity, that is equivalent to area of voids multiplied by seepage velocity. No, divide or multiplying both sides of the equation by the length of flow or the length of soil sample. Ito yung length natin, which is parallel to the direction of flow. No, mapapansin nyo dyan, area ng voids times the length of flow. Ito yung area ng voids that is perpendicular to the length. Parang area lang ng prism, di ba? Base times height. No? Or parang volume lang ng prism, base times height. So, AV times L is the volume of voids. AS times L is volume of solids. No, multiplied by discharge velocity. Again, AV times L is the volume of voids times seepage velocity. No, dividing both sides by volume of voids. Na-cancel na to. No, ano natira dito sa side ng equation na to? That is seepage velocity. No, simplifying this side of the equation, what is VV over VV? That is 1. Plus VS over VV, re-retain as is, and then discharge velocity. But according to our first topic, properties of soil, dinefine natin yung void ratio. That void ratio is the ratio of the volume of voids with respect to the volume of solid. Mapapansin nyo, VS over VV to, ang void ratio VV over VS. Kabaliktaran. No? Therefore, we can say that VS over VV is the reciprocal of void ratio. So with that, VS is equivalent to 1 plus 1 over E multiplied by discharge velocity. No, simplify this term. Get their LCD. We can say that seepage velocity is 1 is equivalent to E over E. Diba? Kaya ito magiging E plus 1 over E. No, E over E is 1 plus 1 over E is 1 over E multiplied by discharge velocity. Again, going back to our first topic, property of soil, we define the porosity. That porosity in relation to the void ratio is E over 1 plus E. Ano nang papansin nyo? Kabaliktaran na lang na naman, di ba? So, 1 plus E over E is the reciprocal of porosity. So, Vs is equivalent to 1 over N multiplied by discharge. We can say that, simplify lang natin ulit, seepage velocity is V over N. Yun na yung equation kanina nakita natin. No? Ang porosity, less than 100% yan palagi. Less than 1. Kapag nagde-divide tayo ng less than 1, anong nangyayari sa result? Nagiging mas mataas. No? And that makes seepage velocity greater than or faster than discharge velocity. No? So memorize this equation, no? Familiarize yourself with respect to the parameters involved in this equation. No? Napakadali lang naman dahil hindi mahaba yung ating equation. No, now we have here the formula for hydraulic conductivity. That hydraulic conductivity of soil is related to the properties of fluid flowing through it by the following equation. No, ito daw tayo, K is equivalent to gamma of W or gamma ng water divided by nu multiplied by K bar. No, gamma W is the unit weight of water, which is a constant term, 9.81. Nu is the dynamic viscosity of water, yung lapot, no? Ganyan din mismo yung variable kay fluid mechanics, no? So alam nyo na yan. K bar is the absolute permeability. No? Ang ating hydraulic conductivity, ang ibang term yan is coefficient of permeability. No, parehas na yung dalawang yan. No, kaya lang geotechnical engineers also use coefficient of permeability. No, ito talaga yung una na term na ginagamit ng mga geotechnical engineers to describe the flow of water flowing in a soil sample, to describe the value of K. But then, this term, permeability, can generate some confusion because it has at least two definitions. No, ginagamit siya as coefficient of permeability and then meron tayong K-bar which is absolute permeability. No, baka mapag-interchange yung dalawang variable na to, which is different. No? So ngayon, to avoid confusion, ang mga geotechnical engineers nag-adjust na. No? Instead na coefficient of permeability yung ginagamit, hydraulic conductivity na lang yung term na ginagamit nila. So this term is used by geotechnical engineers. No, to describe the flow. Etong absolute permeability, ginagamit yan ng mga hydrogeologists. No, kaya talaga itong topic na to ay na di-discuss din kay hydrology. Ano yung difference ng dalawa? Ang hydraulic conductivity, merong dimension na L over T. No, length over time. Ang absolute permeability, merong dimension na L squared. No? So po pwede yung unit niya ay centimeter squared, meter squared, kilometer squared. Dito naman ay cm per seconds, kilometers per hour. May pagka-velocity yung dimension niya. No, yung pagkakaiba ng dalawa. And then sabi dito, absolute permeability is independent of the permeant properties. When we say permeant, it is the fluid flowing in a soil sample. Ano ba yung fluid? Fluid na nagfo-flow sa lupa. Yung tubig. No? So it is independent kahit na anong fluid, hindi man tubig yan, kahit na anong fluid yung mag-flow doon, hindi nagbabago daw yung absolute permeability ng lupa. No, pag minsan yung absolute permeability, tinatawag din siyang specific permeability and intrinsic permeability. No, para-parehas yung mga terms na yan. No, so that is the formula we are going to use on how to calculate hydraulic conductivity. Now, we have also laboratory determination of hydraulic conductivity. And we have two methods under that. First one is the constant head. The second one is the falling head. Doon pa lang sa ating pangalan ng dalawang test, alam nyo na kung anong nangyayari. No? Ito yung setup mismo ng constant head test. Oops. Ito yung setup ng constant head test. Nandito yung lupa natin. No? And then, itetest natin yung permeability. Itetest natin yung flow ng tubig dyan sa lupang yan. Nandito yung inflow. Yan, mag-uumpisa. No? Kung saan nag-umpisa yung flow, mas mataas dapat yung level ng tubig doon. That is why mas mataas to. Nandito yung outflow, dito mag-e-end yung flow natin. Kaya mas mababa yung level ng tubig dyan. No? Kasi nga, from high energy to low energy. No? Throughout the duration, pinapanatiling constant yung difference ng dalawang heads na yan. No? Pinapanatiling constant yung head loss natin dito. Paano yung magagawang constant yan throughout the duration of the test? Kung ano yung inflow, siya rin yung outflow dapat. If this is 10 cubic meters, ito dapat ay 10 cubic meters din. Hindi pa pwedeng mas mataas, hindi pwedeng mas mababa. No? So that is the constant head test. At para daw ma-compute yung hydraulic conductivity using this method, you can use this equation. That is QL over HT. Take note, may Q. Meron din tayong small letter Q na ginagamit. But small letter Q is regarding flow rate. No? Ang Q dito, that is the volume water collected. So para hindi kayo nito, pwede yung gawin siyang VL over AHT. No? Since volume na din pala yung Q na yan. No, L is the length of permeameter. When we say permeameter, that is your meter on how to calculate the permeability or hydraulic conductivity. Ano yung meter nyo? That is the soil specimen. The length of soil. A is the cross-sectional area of the soil. H is the constant head. And T is the duration of the test. No, so that is constant head. Next one, falling head. From the term itself, nagde-decrease yung value ng head loss natin. No, from the term falling. No, ito yung soil natin. I-measure natin permeability. So nandito yung inflow, nandito yung outflow. No, initially at time equivalent to 0, ito yung head loss natin represented by H1. No, at a time equivalent to T or any duration, bumaba yung level ng tubig kasi nga mas madami yung outflow compared kay inflow. No? So bababa yung ating head difference, naging H2. So kadala yung ating head setup ng falling head. No, hindi natin siya pinapanatiling constant. No, so mas okay to. And how to calculate the hydraulic conductivity regarding falling head test? You can use this equation. No, naka-base of 10 yung logarithm natin dito. Ngayon, para mas sakto yung mako-compute natin, pwede natin siya i-express in natural logarithm. Magiging AL over AT, ln of H1 over H2. No? Naka-base of E, no? Or Euler number. Etong dalawang equation na to paras lang. Naka-logarithm to the base of 10, eto naka-natural logarithm to the base of E. Same value yung mako-compute. Mas sakto nga lang ito. Ito kasi yung 2.303, medyo may katuloy pa yan. No, hindi. Tuloy-tuloy yan. So, nandito yung mga parameters involved in that equation. So, memorize this equation. No, that is laboratory determination. Next one we have here, approximation or estimation of the value of hydraulic conductivity. No? So madami ulit tayong mga scientists na nag-conduct ng studies and nag-develop ng mga equations on how to estimate or approximate the hydraulic conductivity. First one, we have Hazen in the year of 1913. Yung formula yung dinevelop niya, magagamit for a fairly uniform sand, granular sandy soil. Ito yung kanyang formula ng hydraulic conductivity, that K is equivalent to C D10 squared, where D10 is the effective size or the diameter at a 10% passing. Dapat naka-millimeters daw kapag isusubstitute. No? And then, K, naka-centimeter per seconds na automatic. Basta naka-millimeters yung D10. Meron tayong constant value, C, which varies from 1.0 to 1.5. No, kailangang ibibigay to. Sir, paano kapag hindi binigay yung C and then gagamitan ng Hazen? You can use the average value. Ano bang average from 1.0 to 1.5? 1.25. No, so that is Hazen equation. Next one, we have Kozen-Kármán equation. No, nag-develop siya ng equation on how to calculate the hydraulic conductivity of sandy soils. No, pertaining to sand pa din. Ito yung kanyang dinevelop na equation or kanilang dinevelop dahil dalawang scientists yan. No, medyo mahaba yung equation na dinevelop nila. 1 over CS SS squared T squared, unit weight of water, mu, E cube over 1 plus E. Ito na yung mga parameters involved in that equation. CS is the shape factor, which is a function of the shape of flow. Excuse me. Natching ako. Okay, CS is shape factor, which is a function of the shape of flow channels. And that is the ratio of the number of flow with respect to the number of drops. No, NF over ND. So later on, that will be discussed in a flow channel. No? So channels, nag-solve na din kayo, di ba? Hydraulics. No? And then SS is the specific surface area per unit volume of particles. So surface area, you're already familiar with that. T is the tortuosity of the flow channels. Gamma W is the unit weight of water. Mu is the dynamic viscosity of the permeate. And then E is the void ratio. No? Ang daming involved na parameter. Ngayon, etong naka-multiply na to, na term na to, can be considered as a single variable. No? Kaya yung equation ni Koza ni Karman po pwedeng gawing K equivalent to C multiplied by E cube over 1 plus E. No? Etong term na to pwedeng gawing constant variable C. Again, this variable C is a constant variable. When we say constant, hindi nagbabago. Magbago man yung value ni K, magbago man yung value ni void ratio, hindi magbabago yung variable C natin. Dahil constant siya all throughout. No, so that is Kozen-Karman. Now we have also here Carrier equation na nag-modify ng equation ni Kozen-Karman. Minodify lang niya. Bakit? Parehas lang silang may E cube over 1 plus E. No? Eto, iba lang yung naka-multiply. Iba lang yung kanyang constant variable C. No? May mga parameters involved dyan. Fi, DLI, DSI, SS. Yung SS dyan parehas ng kanina. The surface area per unit volume of the solid grains. No? And then meron tayong Fi. What is Fi? The fractional difference between two fractions. No? Fractional difference between two fractions, makukuha nyo yan kapag nag-conduct tayo mismo ng particle size distribution. No? When we say particle size distribution, nagawa na natin yan. Mechanical analysis, sheave analysis. No? Kung paano tayo mag-compute mismo ng sheave analysis problem nun, nandun mismo yung term na Fi, fractional difference. Later on, malalaman nyo kung paano i-compute yan. DLI, what is DLI? That is the diameter of the larger opening of sheave. No? Di ba sa ating sheave analysis, may mga different openings yan. No? Sabi nating opening nito ay 2 millimeters. Sunod ay 0.85. Ito merong percent fraction. Sabi natin 90%. Ito 80%. No? So, ito yung DLI. Diameter of the larger opening sheave. Ano yung DSI? Diameter of the smaller opening sheave. Ito yung smaller. Kasi mas makipot kesa dun kay 2. No, ano may Fi? Sabi natin that is fractional difference between two fractions. Ima-minus lang natin dalawang yan. And the fractional difference is 90 minus 80, which is 10%. That is Fi. No, and then, minodify na naman niya yung ginawa niyang equation. There is a slight modification. No? Yung 0.5 na exponent, ginawa niyang 0.404 and then 0.595. Ito na yung pinaka-latest modification niya. No? So, mas gamit ito kesa to. No? Mas gagamitin natin nasa ilalim kesa yung nasa itaas. No? Siyempre, gagamitin natin pinaka-latest na equation niya. So, that is Carrier equation. Again, that is for sandy soil also. Dahil minodify niya yung kay Cozen ni Carmen. And then, we have also here, dinevelop na equation ni Samarasinghe and others. No, meron siyang kasama dalawa. Si Dernovich and then Wang. No, itong tatlong to nag-conduct ng studies on how to calculate the hydraulic conductivity of a normally consolidated clay. Ito yung na-develop nila, where K is equivalent to C multiplied by E raised to N over 1 plus E. Again, variable C and variable N are constant value. Magbago man yung K, magbago man yung E, hindi magbabago yung value ni C at saka ni N. No? So, these are the empirical equations we are going to use. No? Next one, equivalent hydraulic conductivity in a stratified or layered soil. No? In actual condition, hindi lang naman iisang soil sample yung nasa ilalim ng ground surface natin. No? It is a combination of different kinds of soil. Layered siya. No? May pagka-metamorphic. No? So, na-discuss na natin yan kay geology kung paano na-form yung stratified or metamorphic kind of soil or rock. No? So, ngayon, yung binanggit kanina, iisang layer, iisang soil sample. Paano daw kapag madaming layers, madaming soil sample? No, and then i-compute natin yung total hydraulic conductivity or yung equivalent hydraulic conductivity ng lahat ng layers na to. Siyempre, yung bawat layer may kanya-kanyang hydraulic conductivity. No, paano kapag pinagsama-sama daw natin yun? Ano yung gagawin natin? Hindi lang daw natin siya basta-basta pina-plus. No? Okay, so, under this topic or subtopic, meron dalawang condition. No? First one, if we have a horizontal flow. The second one, kapag meron tayong vertical flow. No? Paano natin malalaman na horizontal flow? Not necessary na horizontal yung direction ng flow, horizontal flow na din. No, hindi palagi. Po pwedeng paganyan yung flow natin and then po pwedeng yung maging horizontal flow. Depende sa orientation ng stratified soil. Under horizontal flow, the flow or the water will enter or will flow at the stratified soil at the same time. No? Pare-parehas at the same time sila papasukin ng tubig. Kung nandito yung flow natin, part of it papasok dito sa first layer, part of it kay second layer, kay third layer and so on. No, papasukin niya yung mouth layers at the same time. No. And then that is horizontal flow. And sabi dito, under horizontal flow, we have a constant hydraulic gradient condition. Ano ba yung hydraulic gradient? Na-define na natin kanina. That is I. Ano ba yung I? Head loss over length. No. Paano ba magiging constant yung hydraulic conditions natin in this layered soil sample? Dapat, parehas yung head loss, parehas yung length. No. Ang ibig sabihin lang yan, in this layered condition under horizontal flow, kahit saan tayo maglagay na point ng piezometer, pare-parehas yung level ng tubig. Maglalagay ka ng piezometer dyan sa first layer, nandyan yung level niya. So, maglalagay ka ng piezometer the second layer, nandyan pa rin yung level ng tubig. Para-parehas yung total and how do we say? Yes, para-parehas yung total energy. No? At every point of the soil. Kay third layer, nandyan pa rin mismo yung level ng tubig. No? At this outflow, ganun din mismo. Dito sa inflow kasi ganyan. Sa outflow, ganyan din mismo. Kapag maglalagay ka ng pipe sa first layer, nandyan mismo yung level ng tubig. Pag maglalagay ka mismo ng piezometer din sa second layer, nandyan din pa rin. No? Pare-paras yung ating total energy, no, develop at every point under horizontal flow. No? So kung pare-parehas yan, at every point, pare-parehas yung head loss natin, di ba? No? And then length, dapat pare-parehas din. Ano ba yung length? It should be parallel to the direction of flow. Nandiyan yung direction of flow natin, no? Nasaan ba yung parallel distance dyan? Eto. Nandito yung inflow, nandito yung outflow, ito yung length. For the first layer, second layer, third layer, and so on, pare-parehas yung length natin. Kung pare-parehas yung head loss, pare-parehas yung L, constant mismo yung hydraulic gradient natin at every point. No? Nila yung ibig sabihin nun. And horizontal flow condition is analogous to resistors in series. Parang nag-a-analyze daw ng series connection doon sa circuits noon. No? So, in this horizontal condition, sabi nga natin, the total flow, papasukin niya yung first layer, second layer, third layer, a part of it, dun sa ibang layer. So, we can say that the total flow rate is equivalent kay flow ni first layer plus flow ni second layer plus flow ni third layer and so on. No, di ba ganyan yung ating series connection? That the total resistance is equivalent to R1 plus R2 plus R3 and so on. So analogous tayo kay series connection dun sa circuits. Ganyan lang din mismo yung gagawin natin. Eh sabi natin, ang flow rate, that is the product of area and discharge velocity. No? And ang discharge velocity, according to Darcy's law, discharge velocity is the product of K and I. No? So, yung ating formula ng flow rate. So, total flow rate is KIA, total conditions. No? For the first layer, KIA din yan, pero gagamitin natin mismo yung parameter mismo ni first layer. Plus KIA ni second layer plus KIA ni third layer. And so on, kung madaming layers pa yan. No? Ito yung ina-analyze natin, yung K total. The equivalent hydraulic conductivity ng layers na yan. No? Eh anong sabi natin? At a horizontal flow, the hydraulic gradient is equivalent, constant. So yung I na to, yung I na yan, I dyan at saka I dyan, pare-parehas. No? Kaya magka-cancel lang since pare-parehas yung values nila. No? So natira yung K at saka A. So K total. Ano yung K total? Yung total na to ay yung tinatawag nating equivalent hydraulic conductivity. Kaya lang in a horizontal condition. No? Kaya tinatawag siyang KHEQ. Equivalent hydraulic conductivity. Or equivalent horizontal hydraulic conductivity. No? May direction. And then area total. Ang area, it should be perpendicular or normal to the direction of flow. Nandito yung direction, oh. So, nasan yung area? Eto. No? Linya lang yung nakikita natin kasi nga, two-dimensional lang yung ating figure. Pag ginawa natin three-dimensional, meron tayong width dyan. No? So, assume natin yung width dyan ay 1 or any value. O okay lang mismo kahit anong value yan. So, assume natin unit width. The area total is 1, that is the base, multiplied by the height. Ano yung height ng total? Ni total H. Kasi total flow yung ina-analyze. No, so from this point to this point, which is total H. That is area total. The base is 1 unit, the height is H. Equivalent to the hydraulic conductivity of first layer. Mapapansin nyo dyan, hydraulic conductivity, may dalawa. May naka-H, may naka-V. Anong gagamitin yung hydraulic conductivity kapag dalawa yung value na kinonsider? It should be parallel to the direction of flow. No, ano ba yung parallel dyan na direction of flow? Etong KH, di ba? Parallel siya dyan sa direction ng flow. So, kung paganyan tayo, etong KV yung gagamitin nyo. Okay, so, K of first layer is KH1. Gawin lang natin K1, but that should be KH1. No? Pwede yung gawin KH1 yan. Kaya lang, ang dami mismong variable. Gawin ko na lang K1. But that should be H. Or that should be parallel to the direction of flow. And then, area ni first layer. Ano ba yung cross-section ni first layer? Ito lang yung first layer, oh. Nandito yung area niya. Itong line na to. No? So, dapat may width yan na perpendicular dun sa flow natin. Ang inassume nating width ay 1 unit. So, parang may pagka-rectangular, base is 1, a height of h1. No? So, ito ay k1, h1. No? And then dito naman magiging k2, h2 plus k3, h3 and so on. No, merong 1 mga yan, h1 times 1, h2 times 1, h3 times 1. Kaya lang, magka-cancel lang din. No? Kahit nyo hindi ilagay yan, okay na. Ang kino-compute yung total, that is KH, EQ, yung equivalent hydraulic conductivity. Para mako-compute yun, alisin yung H. May cross multiplication. So that will become K1, H1, plus K2, H2, plus K3, H3, over H. Yan ang ating formula for the equivalent hydraulic conductivity for a horizontal flow. No? No, napakadaling i-memorize lang naman yan. Next one, we have the vertical flow. No, pag sinabing vertical flow, the total flow or the water will enter the layers of soil one at a time. Hindi siya sabay-sabay. No, one at a time. Papasukin niya muna yung first layer, saka siya papasok kay second layer. Pagkatapos niya dyan, papasukin niya yung third layer. Pagkatapos niya kay third layer, papasukin niya yung fourth layer. One at a time niya pinapasok or one at a time siya magpo-flow sa mga layers ng soil. No? So that is the difference of vertical flow and horizontal flow. No? Ngayon, eto, ginawa lang natin siyang upward flow. No? Pwede rin naman downward flow. No? Kung mapapansin nyo, may mga pipes or piezometer na nakalagay dyan. Anong sabi natin? Kung saan mismo mag-start yung flow, nandun yung pinaka high energy. No? Dito mag-start yung ating flow. And then dito mag-end sa taas. So kung maglalagay tayo ng piezometer sa point of, or sa starting point natin, ito yung piezometer na to, dapat yung piezometer na yung pinakamataas na total energy head. No, kasi nga nandyan yung starting point of flow natin. So nandun yung pinakamataas na total energy. Kung saan mismo magtatapos, nandun yung pinakamababang energy head. Kaya eto, dito tayo nagtapos, nandito yung pinakamababa. What if nandito yung flow natin, mag-i-start mismo dun sa ibabaw, papuntang ilalim. Dito mag-i-start, di ba? So dapat yung pipe dito na nakakabit mismo sa starting point na yan, pinakamataas dapat yan. No, eto na yung pinakamababa. Etong mga to, it follows. So mas mataas din yan, mas mataas din yan, eto mas mataas din yan. Kakaroon tayo ng head losses. No? There is a head loss papunta sa pinaka last point natin. No? And as you can see here, papunta sa last point, nagkakaroon ng head losses pababa. No? Okay, so that is a vertical flow. Ngayon, sabi natin, it will flow at the layers of soil one at a time. Therefore, we can say that total flow is equivalent sa flow rate ni first layer, equivalent sa flow rate ni second layer, equivalent sa flow rate ni third layer, and so on. No, kung ano yung nagflow sa total condition, siya rin yung nagflow kay first layer, siya rin yung nagflow kay second layer, and so on. No, again, anong sabi natin kay flow rate? That is KIA. Ay ito ay KIA, total condition. Ito ay KIA, first layer, equivalent kay KIA, second layer, equivalent kay KIA, ni third layer, and so on. No, ito yung ina-analyze what is the hydraulic conductivity total condition, yung equivalent condition. Kaya K total is K equivalent. Kaya lang vertical flow condition. No, ano yung hydraulic condition total or total hydraulic gradient? No, ano yung hydraulic gradient natin ay that is the ratio of head loss with respect to the length. No, Yung total natin, eto yung total head loss natin, that is H. Nasaan yung total length? Ang sabi natin, length should be parallel to the direction of flow. Eto yung direction of flow, nasaan yung parallel distances dyan? Eto. So the total length is H. So head loss is H, length is H. So hydraulic gradient, total condition is H over H. No. How about the area total? Papasin nyo, nandito yung area dito. Area total. And then area ng layer na to. Ito yung area ng layer na yan. Ito yung area ng layer na yan. Ito yung area ng layer na to. Ito yung area ng layer na to. Pare-parehas yung cross-sectional area at every layers and at total conditions. Kaya yung A dito, cancelled. So we can say that Ki, total condition, is equivalent to Ki ng first or any layer of soil. Ano ba yung Ki? Discharge velocity. So discharge velocity ay equivalent. No? Under vertical flow. So cancel na yung ito lang natira. Equivalent sa K ni first layer. So K1. Again, ang gagamitin na K ay parallel sa direction ng flow. Ito yung direction ng flow, ito dapat yung gagamitin nyo. No. Paano kapag iisa lang yung K na binibigay, sir? Pag iisa lang yung K na binigay, we assume na yung KH at saka KV ay parehas. No? Anong ibig sabihin kapag KH at saka KV ay parehas? Ibig sabihin isotropic yung condition natin. No. Paano kapag yung KH at saka KV ay hindi parehas? Ibig sabihin anisotropic. Anisotropic or non-isotropic. No. Ang ibig sabihin lang nun sa isotropic, para-parehas na spherical grains. Pare-parehas yung shape. Pare-parehas yung flow at every corner. No? At every directions. No, kung ano yung flow horizontally, yun din yung flow kay vertical direction. That is isotropic. Kasi nga, bakit magiging pare-parehas? Pare-parehas mismo yung shape. Pare-parehas na spherical grains. With the same masses, with the same shape, with the same volume. No, yung solid grains natin. Sa anisotropic, magkakaiba yung shape ng solid grains natin. Pag magkakaiba yung shape ng solid grains natin, hindi pare-parehas yung flow at every direction. And that makes it anisotropic condition. Later on, i-discuss natin yan. Okay, so balikan natin to. So that should be K1. No, yung K na gagamitin should be parallel to the direction of flow. And then I of first layer, hydraulic gradient of first layer. Again, that is head loss over length. Analyze natin yung first layer. Ito siya. Ito yung starting point ni first layer. Ito yung final point is first layer. Nandito yung mga pipes na nakakabit sa starting point tsaka ang ingay. Sorry. Maingay sa labas. Nandito yung starting point. And ito yung pipe na nakakabit sa starting point ni first layer. Nandito yung final point. At ito yung piezometer na nakakabit sa final point. Kung i-analyze natin yung level ng tubig sa dalawang piezometer na yan, merong difference of head. Meron siyang head loss. And that H1 is the head loss of this layer. No? And then, ano yung length niya? Should be parallel to the direction of flow. Ito yung length. So, H1 over H1 yung hydraulic gradient. Kaya ito ay H1 over H1. No? Papasin may parang may ano na kayo dyan, no? Hint na kayo kung paano itutuloy yung equation. No? So, for the second layer, K2, H2 over H2 equivalent to K3, H3 over H3 and so on. No? Now, analyze the total head loss. The total head loss of this layered soil is the summation of the head losses of each layer. Diba? So kung ilang layers man yan, i-add nyo yun. And then, kung ano yung total head loss doon, yun na yung H natin dito. So we can say that total H is equivalent to H1 plus H2 plus H3 and so on kung madaming layers pa yan. Tama? paano mako-compute yung H1, H2, tsaka H3? Nandito sila. No? And we can have their values by cross multiplication. No? So yung H1, H1 na to, i-cross multiply mo. Yung K1 na to, i-cross multiply mo doon. No? And that makes H1 equivalent to KV equivalent H over H multiplied by H1 over K1. No? Yung H2, i-cross multiply mo lang din dito sa term na to. Tsaka yung K2, cross multiply mo doon. So H2, that will be equivalent to KV equivalent H over H multiplied by cross multiplying H2 over K2. Same with H3. That will become KV equivalent H over H multiplied by H3 over K3. Now substitute this equation into this total head loss equation. You can say that total head loss is equivalent to yung H1, H2, tsaka H3, merong common term. No? Pag finactor out natin common term na KV equivalent H over H, merong matitira. No? Matitira si H1 over K1 plus sa H2, matitira si H2 over K2 plus H3 over K3 and so on. No? Papansin nyo, H to, total head loss din yun. Cancelled. Anong kinocompute natin? KV equivalent. So, cross-multiply lang natin para ma-compute natin equation niya. Therefore, KV equivalent is, etong H na to, pupunta sa taas, etong term na to, pupunta sa ilalim. H over H1 over K1 plus H2 over K2 plus H3 over K3. And so on. Naku, madaming layers pa yan. So that is the equivalent vertical hydraulic conductivity. No? So memorize this equation also. Napakadali lang din yan. And this is analogous sa parallel connection ng circuits natin. Papansin nyo nun sa parallel connection, total resistance is 1 over R1 plus 1 over R2. No, di ba ganyan equation natin noon and so on. So parang halos parehas siya dyan. Sa horizontal, analogous siya kay series connection. Sa vertical, analogous siya kay parallel connection. Okay, so that is equivalent hydraulic conductivity. Next one, we have here field test. Paano natin ginagawa yung field test on the determination of permeability or hydraulic conductivity? That is done by pumping from wells. No, nagpa-pump tayo ng wells balon. No. Ngayon, paano ba tayo gumagawa ng balon? No? Kailan tayo magpapatayo ng balon at saan? No. Siyempre dapat may balon tayo doon para ma-conduct natin mismo yung ating permeability test sa field. Sa subtopic na to, merong dalawang condition. We have unconfined aquifer and then the second one is confined aquifer. For sure na-define na sa inyo yung aquifer, tama? Sa hydrology. Am I right? Hello? Anybody there?
Yes po, sir.
Wala sumasagot. Na-define na ba yung aquifer sa hydrology? No, na-discuss na yan. For sure nakapag solve din siguro kayo ng problems regarding this field test. Tama ba? Ayan, wala na naman. Nag-ghost na naman ako. Ang hilig naman mang-ghost ng section na to. Grabe, lahat na lang. Drama. Hello po. Nakapag-solve na po ba kayo ng problems regarding this subtopic? Field test? Madalas sumasagot. Sino na to? John Froy, nakapag-solve na kay Utoy?
Para pong yung mga confined po, mga unconfined, mga ganun po.
Ito nga. Hindi ko na i-discuss to, no? Alam niyo na to.
Limot na po, sir.
Reviewin niyo yung topic niyo noon, no? Limot na. Ano ba yung aquifer? These are geological formations. No? Actually, 4 yan. Ba natin? Ito na nga lang. We have aquifer. We have aquitard. We have aquiclude. Puro aqui, no? We have aquifuge. No? Pero dito, usually, dalawa lang yung nagagamit. Yung aquifer tsaka aquiclude, okay na yon. No? Usually, sila yung nababanggit sa mga problems. Ngayon, ano ba yung mga difference ng geological formations na to? Pare-pares lang naman to. They're all layer of soil sample. Pero ano yung kaibahan ng mga layers na to? Aquifer, there is a flow. No? It permits the passage of water. Yung layer na yan. No? So, ibig sabihin, kapag merong flow, we can compute the hydraulic conductivity. No? Because there is a flow. No? When we say aquitard, it doesn't permit the passage of water from one aquifer to another aquifer. That is aquitard. No? It doesn't permit the passage. Pero po pwedeng mag-sip. No? Pwedeng mag-sip pataas or mag-sip pababa yung tubig papunta sa ibang aquifer. Pero walang flow talaga. Magsisip yan kasi nga tubig yan, di ba? No, kahit walang flow doon, walang definite direction ng flow doon, po pwede talagang mag-sip. No? Kasi nga mababasa yung mga solid grains. Kapag nabasa yung mga solid grains, naapektuhan yung ibang katabing solid grains hanggang sa nagsisip na yung ating tubig from one direction or from one aquifer to another aquifer. But there is no flow. It doesn't permit the passage of water. But it can sip. That is aquitard. No, aquiclude, there is a little flow, negligible value, no, almost no flow at all. That is aquiclude. Sa aquifer, it permits the passage of water. Sa aquiclude, it doesn't permit the passage of water. No, same with aquifuge. Yung aquiclude, negligible value. Yung aquifuge, there is no flow at all. No. And then, hindi pa siya makakapag-sip dyan. No? So, yung kaibahan ng 4 na geological formations na yan. No? Kung i-drawing natin, ito yung aquifer. No? Ito yung pagkakadescribe ko, ha? No? Pwedeng magkabali-baliktad yung bawat layers na yan. Ito yung aquitard. This is aquifer. This is aquiclude. Pwede rin siyang aquifuge. No. Okay, so paano magkabali-baliktad yan, ha? No? Ito yung aquitard. Yung sinasabi ko kanina, it doesn't permit the passage of water from one aquifer to another aquifer. Ibig sabihin, yung aquifer dito, hindi siya magfo-flow papunta dyan. Walang direction dyan. Walang direction of flow ng tubig. Pero po pwedeng mag-sip. Kasi nga, mababasa yan. Yung mga solid grains kay aquitard, mababasa and then magsisip pataas or pababa yung tubig. Pero walang flow talaga dyan. Pag sip, mabagal yun. Pag flow, mabilis yun. No? So, yun yung aquitard. Ngayon, meron tayong dalawang condition. Unconfined tsaka confined. No? Yung unconfined, ito yung setup. Ito yung aquifer, itong slight blue or aquifer, itong medyo maputlang blue, itong medyo dark blue dito, this is the impermeable layer. When we say impervious or impermeable layer, there is no permeability. There is no flow. Kaya po pwede yung i-consider na aquiclude. Aquiclude. No? So, yung mapapansin sa setup ng unconfined, nasa pinaka-itaas na layer yung aquifer. Yun dapat yung setup niya. Hindi siya confined. Hindi siya napapalibutan ng aquitard, hindi siya napapalibutan ng aquiclude or aquifuge. Ang meron lang ay yung nasa ilalim niya. No, wala dun sa itaas. And that is unconfined. No, kumbaga etong aquifer na to, ito yung unconfined. Hindi siya napapalibutan. No, etong aquifer dito, napapalibutan siya ng aquitard, aquiclude, or aquifuge. No, so that makes this aquifer confined aquifer. No. So, pag minsan naman sa mga problems, hindi binabanggit yung term na aquifer tsaka aquiclude. No. Paano natin malalaman kung meron tayong aquifer or aquiclude doon? Para malalaman na merong flow or walang flow. Pag merong binanggit na sandy layer of soil, that is, there is a flow. No? So, it can be considered as an aquifer. Pag sandy layer. Kasi nga, malalaki yung solid grains. Pag malalaki yung solid grains, mas mataas na lumuluwang. Mas mataas yung chance na luluwang yung ating void or pore spaces kung saan magpo-flow yung tubig. So, merong flow kapag sandy layer. Kapag aquiclude, clayey layer of soil. No, clay layer of soil. Dahil ang clay layer, maliliit yung solid grains. Kapag maliliit yung solid grains, yung mga void spaces between these solid grains ay napaka-konti. So, hindi niya pina-permit yung passage of water. No. So, yan yung mga hint nyo para malaman kung anong condition natin, no? Ngayon, meron tayong pump dito or test well. No, ito yung malaking test well natin. Then maglalagay rin tayo ng observation well. No, ipapump daw natin yan. Kukuha daw tayo ng tubig sa test well na yan. Originally, nandyan yung level of water. Nandyan yung groundwater. No? Ngayon, ipapump natin. Pag pinump nyo, syempre, bababa yung level ng tubig sa test well natin. No, magiging ganito na. Kung saan tayo kumuha ng tubig, kung saan tayong point kumuha, nandun yung pinakamalaking bawas daw. Nandun yung pinakamalaking drawdown or pagbaba ng level ng tubig. Yung ibang part, maapektuhan. Bakit maapektuhan? Kasi nga, etong part na to ay aquifer. Parehas ng natubig yung nagpo-flow dyan. Therefore, maapektuhan yung level ng tubig sa ibang part. Pero, hindi ganon kalala yung drawdown compared mismo sa drawdown kung saan tayong point kumuha. No? So, ganyan daw yung relationship. Ganyan daw yung pagka-curve ng drawdown natin. So, may drawdown dito, may drawdown. Habang papalayo ng papalayo, hindi siya naapektuhan ng pag-drawdown due to pumping of wells. No? So, gano'n lang yung setup natin. We have here variable R1, R2 that is center-to-center distances ng test well tsaka observation well natin. H1 and H2, that is the height of water in these observation wells. No? At paano daw mako-compute yung ating hydraulic conductivity? We can use this equation. Ito naka-logarithm to the base of 10 na naman. Pwede natin gawing natural logarithm. Q or the flow rate multiplied by loan quantity R1 over R2 over pi H1 squared minus H2 squared. No, yung ating equation. So that is unconfined. Etong aquifer na to, yan yung principle na ginagamit natin para makapagpatay ng balon. No, para makapagpatay ng gripo. No, kung bakit meron tayong spring or bukal. No, bakit hindi natutuyuan ng laman, nawawalan ng tubig yung balon. No? Kasi nga, meron tayong aquifer doon. No? Compare nyo na lang to. Meron tayong water table dyan. No? And this layer is an impermeable layer or aquiclude. Ngayon, magpapatayo kayo ng gripo. Pag magpapatayo ng gripo, meron tayong pipe na pinepenetrate dun sa lupa natin, no, para makakuha or makapag-pump tayo ng tubig. So okay na 'yan, di ba? Kasi meron tayong groundwater table. No? Pag nag-pump tayo, etong groundwater table bababa. Throughout time, bumababa yung level ng tubig. Ngayon, kung impermeable layer 'yan, hindi agad-agad nare-replenish yung nawala or pinump mong tubig. No? So dapat maglalagay tayo mismo ng pipe kung saan merong aquifer. Dahil yung aquifer, tuloy-tuloy yung agos ng tubig. No? Kahit mag-pump ka dyan ng tubig, sa gripong yan, mare-replenish agad yung tubig na nawala. Kasi nga, merong nagfo-flow na tubig dyan. No? Dito, impermeable layer, antayin mo pang umulan para ma-replenish yung tubig. And then, impermeable pa siya. Mabagal pang mag-flow or mag-seep yung tubig dyan. No, para ma-replenish yung water table. No, dito kahit hindi umuulan sa part na yan. No, kung umulan doon sa ibang part, lahat ng aquifer interconnected yung mga yan. No, parang rivers lang. Interconnected to each other, there is a flow. Umulan dito sa part na to, yung aquifer doon, pupunta dyan or magfo-flow dyan, papunta. So, may na-flow na tubig, nare-replenish yung nawawala or pinapump mong tubig. No, that is a pumping of wells. No, wala. Sinabi ko lang naman yon, pero hindi related yun sa topic natin. Charot. Okay, so, we have here also confine. No? Parehas lang. Ito yung equation, may konting discrepancy lang or pagkakaiba. No, just make sure ha, aalamin nyo kung unconfined or confined yung ating aquifer para alam nyo kung anong formula yung gagamitin nyo. No? Dapat nandito yung aquifer core for confined, nandito yung aquifer core for unconfined. So ito na yung formula. Ito po pwede naka-natural logarithm. Equation natin. No, this is natural logarithm, where h here is the thickness of the aquifer. No, yung H1, H2, yun yung height of water in the observation well. R1, R2, center to center distance ng test well tsaka observation well. No, Q is the flow rate in L cube over T. No, alam nyo na mismo yung dimension ng flow rate. Dapat L cube over T siya. No? Okay, so this is our field test. So, para mas ma-familiarize tayo sa topic natin, let's take examples. So, we have here, the hydraulic conductivity of a clay soil is equivalent to 3 times 10 raised to 7 centimeter per seconds. The dynamic viscosity siguro. The dynamic viscosity of water at a temperature of 25 degrees Celsius is given as 0.894 times 10 raised to negative 3 Newton seconds per square meter. Calculate the absolute permeability of soil or K bar. No? So, isa lang naman yung equation na present natin regarding absolute permeability. No? And we can use this equation that hydraulic conductivity is equivalent to unit weight of water multiplied by absolute permeability divided by viscosity. No? Yung mga yun binigay na, no? You have the hydraulic conductivity, you have the viscosity. Unit weight of water is a constant term. No? So, mako-compute na natin yung unknown, which is absolute permeability. Okay, substitute. Hydraulic conductivity is 3 times 10 raised to 7 centimeter per seconds. Equivalent to the unit weight of water 9.81 kilonewtons per cubic meter. Naka-newtons yung viscosity. So convert nyo na kay newtons. 9,810 newtons per cubic meter. That is unit weight of water. And multiplied by the unknown absolute permeability divided by viscosity given as 0.894 times 10 raised to negative 3 Newton seconds per square meter. Observe the units, dapat consistent. No, newtons cancelled. Seconds cancelled also. Cubic meter, square meter cancelled. Merong natirang 1 meter. Yung 1 meter na to nasa denominator. No, i-cross multiply natin, mamumultiply kay centimeter. So hindi siya consistent, centimeter times meter. I-convert natin. No, conversion, that is 1 meter is to 100 centimeter. Cancelled yung meter, cancelled yung 1 meter. No? So the unit is centimeter squared, which is the unit for absolute permeability. Dapat naka-L squared tayo. No? So, simplify. What is absolute permeability?
$273.39.
273.39 centimeter squared. Parehas po ba sa iba?
Yes po, sir.
Okay, so that will be the requirement of this problem. No? Napakadali lang. No? Direct substitution. Ayan na naman, sister, no? Direct substitution daw. Pag exam, ba't parang ganun? Okay. Next one. The hydraulic conductivity of a sand at a void ratio of 0.5 is equivalent to 0.02 centimeter per seconds. Estimate the hydraulic conductivity of this sand at a void ratio of 0.65 using Kozeny-Karman and Casagrande equation. Yung Kozeny-Karman, na-present ko na yung equation kanina. The Casagrande equation, wala kong present dun sa empirical relationship. No, dahil sa ginagamit nating reference book ni Brahadas, wala dun yung Casagrande equation. No? Kaya hindi ko na rin nailagay yung Casagrande equation. But then later on, ipapresent ko sa inyo pag sinolve na natin. No? Let's have first Kozeny-Karman. Okay, sa Kozeny-Karman, let's write down first the given. Meron tayong hydraulic conductivity in centimeter per seconds and its corresponding void ratio. Sabi dito, when the void ratio is 0.5, the hydraulic conductivity is 0.02 centimeter per seconds. And we have to calculate the hydraulic conductivity when the void ratio becomes 0.65. Ano daw yan? No. The hydraulic conductivity is directly proportional to the void ratio. No. Kasi nga, kapag tumataas yung void spaces, tumataas yung flow, tumataas yung hydraulic conductivity. No, so kung tumaas yung ating void ratio dito, dapat mas mataas din mismo kay 0.02 yung mako-compute natin value ni K. No, with respect to a void ratio of 0.65. So yung hint nyo. So paano nyo mako-compute yun? Using Kozeny-Karman muna daw. Ano yung equation niya? That K is equivalent to C E cubed over 1 plus E. No, where C is a constant term. No, so substituting, when the value of K is 0.02 centimeter per seconds, the value of void ratio is 0.50. So sinubstitute lang natin. So with that, given set of values, we can compute for the constant value of C. So kindly compute.
0.24 po.
0.24 centimeter per seconds. No? Store natin kay Ipan, ito nag-round off. So, etong set of value na to, values na yan, merong C na 0.24. At yung constant C na hindi nagbabago. So, 0.24 din dyan. So, with that, makukompute na natin yung K using Kozeny-Karman. The value of C is 0.24 centimeter per seconds. The value of void ratio is 0.65 raised to 3 over 1 plus 0.65 ulit. So what is K? That should be greater than 0.02. So 0. Ano na pong na-compute?
0.04.
0.04 centimeter per seconds. And that is greater than 0.02. So okay yung na-compute, no? And that is the requirement of this problem. No? So, pwede nyo rin gawin na C is equivalent to C. No? Yung C dito equivalent sa C doon. Ano ba yung C? That is K multiplied by 1 plus E over E cubed. No? Kinuha lang natin yung equation ni C. No? Ito, equivalent doon sa K multiplied by 1 plus E over E cubed. No? Para diretsahan na. Kaya lang ito, dun sa second set of values, and then ito sa first set of values. Para mas madali yung masolve. Okay. So, next one, we have letter B, Casagrande equation. Under Casagrande equation, the formula is K is equivalent to 1.4 E squared C. Where this constant value, constant siya, hindi nagbabago. Magbago man yung K tsaka E, hindi magbabago yung C. No? Where that constant value of C is the hydraulic conductivity of the soil at a void ratio of 0.85. No, that is why pwedeng gawin siyang K.85 yung formulang yan. No? So, ganun pa rin, no? Sabi doon, first set of values, ang K natin ay 0.02 cm per seconds. That is equivalent to 1.4. Corresponding void ratio of this K is 0.5. So, mako-compute natin yung constant C natin. Ano po yung value? So, dapat mas mataas kay 0.02. Dahil yung void ratio ng C na yan is 0.85. Ang talagang naman. Para
0.6 po.
makakapag-determination number na naman.
0.06 po.
Ayun. 0. Agad-agad sinabi. Parang ayaw niya kong pumanta. Okay. That is correct, no? Greater than siya kay 0.02. Ang ibig sabihin nun, kasi yung C na na-compute natin doon corresponds to a void ratio of 0.85. No? So, yung K na na-compute, that is C, which is 0.06. No? Ito yung na-compute natin na value of C. Ang pinapa-compute, when the value of void ratio is 0.65, ano yung K? So, dapat yung mako-compute nyo in between 0.02 and 0.06. No? So, paano nyo mako-compute yun? Using the same equation. What is the value of K? 1.4 when the value of void ratio is 0.65. Again, yung C hindi nagbabago. Ay ito naka-store dapat. No? So, what is K? 0.0 something. No, in between 0.02 and 0.06.
0.34 po.
0.34 centimeter per seconds. Yan yung sagot. No? So, okay naman yung value na compute. So, yan, napakadali lang naman. So, are there any questions with our discussion? Wala ba kung pinasagot last time?
Wala po, sir.
Wait lang. Sino, paki-raise hand button po. Paki-pindot ang raise hand button ng mga participants. Sino pa pa? 4, 5. Tama. 5 lang. Aswar, Santiago, Pagaduan, Bueno, Esguera. Wala na? Walang sinalian si Viel? Tamang nod-nood lang, Viel?
Hindi ko nalaglag yung kalpyo.
Tamang comment lang kapag may event?
Apa.
Opo daw eh. Okay, so bibigyan ko na lang sila ng plus point, no? To be claimed next semester. No? May factor of safety na sila next semester, di ba? Okay, so questions. Mr. Masusi.
Wala naman po, sir.
Okay, wala naman, no? Okay, so review na lang po yung topic, no? Although napahapyawan na kayo doon sa videos na sinend ko sa LMS. Dapat na-review nyo na yan. Siguro next meeting, prepare lang kayo, no? For an exam. Since hindi na tuloy yung exam, prepare lang naman. Pwede ako magbigay or hindi. No? Tumatawa yung iba, ba't parang hindi kayo naniniwala? No? Since tumatawa, parang gusto kong totohanin. Ngayon na laang, no? Ngayon na lang exam. Oral examination. No? Mas maganda pag oral, no? Sa oral tayo magpapalabas. Ay. Charot. Okay, so aray ko. That's it po, no? Since wala nang questions, aralan nyo na lang. And see you next meeting po, no? Prepare, ha? No? Prepare. Okay, good morning po. Pwede na pong umalis.
Thank you po, sir.
Thank you, sir.
Thank you po, sir.
Thank you po, sir.
Sir.